When we think about mastering fire, we usually picture warmth or light or maybe cooking a meal. But what if fire was actually humanity's first real tech revolution? The thing that let us completely reshape our world way, way before the Bronze Age or the Industrial Revolution. So, let's dig into how that happened.
Just try to imagine this for a second. For hundreds of thousands of years, this was the reality for our ancestors. This constant, frustrating struggle of trying to shape hard, unforgiving stone with nothing but muscle. It was inefficient, it was unpredictable, and honestly, it was a total dead end for progress. So the big question is, how did we get from that frustrating thud to creating the kind of sophisticated tools that could build civilizations? Well, the answer, it turns out, was mastering one single powerful element: fire.
Okay, so to really get the impact of this, we first need to look at how humans went from just being at the mercy of natural fire to actually commanding it for ourselves. I mean, just look at this timeline. The amount of time involved here is just staggering. For over 1 million years, we were basically just fire users, not fire makers. The big shift came when we started managing it in hearths, and then, the real game changer, making fire whenever we want it, around 50,000 years ago. They think Neanderthals figured out how to do it by striking flint and pyrite together, and that's when everything changed. All right, so with fire, now a tool in our back pocket, we could finally start tackling the physical problems that held back innovation for so long. Fire became the key that unlocked the true potential hidden inside all these raw materials. You have to understand, before this, every time you tried to make a spear point or a blade, it was a literal fight with the rock itself. You were trying to force the stone to do something it just did not want to do, which meant a ton of errors and wasted effort. And this is where you see that incredible before and after effect. By heating up stones like flint, our ancestors were actually changing their physical properties. The heat made the stone more brittle, which sounds bad, but it actually made it way more predictable. All of a sudden, it wasn't a battle anymore, it was a process. And this opened up a whole new world of materials they could use, stones they never would have touched before. So just how big of a deal was this? Well, we're talking about a 60% drop in mistakes. That is a huge leap in efficiency. It meant more tools that actually worked, with way less wasted time and material. And here's the really cool part. This one breakthrough didn't just help make better versions of the old tools, it kicked off this explosion of totally new technologies that just redefined what was even possible for early humans. What you're looking at here is basically the birth of engineering. It's a system, right? A repeatable process. Instead of just relying on luck and brute force, our ancestors developed a real workflow: prepare the material, shape it, refine it. And that meant better quality and more consistency every single time. And just check out the kind of stuff they could make now. Fire let them create these powerful resins to basically glue stone points onto wooden shafts, creating the first composite spears. They could harden wooden tips in the flames to make them lethal, or bend wood to make the first bows. They even figured out how to cook indirectly by heating stones and dropping them into water to boil it, which was a massive deal for getting more out of their food. Yeah, the numbers here, they really paint a picture. Modern experiments show that heat treating made the whole process 4 to 5 times more efficient. And the tools they made weren't just easier to create, they were 2 to 3 times more durable. That's not just an improvement, that's a revolution in how things get made. Okay, but here's what's truly mind-blowing about all this. It wasn't just about making things hot. The evidence shows they were controlling the temperature with real precision. They figured out that heating flint to somewhere between 350 and 400 degrees Celsius gave them the absolute best results. This wasn't just guesswork. This was the very beginning of material science. So what's the big picture here? What did all this new tech actually do for people? Well, the impact didn't just stay in the workshop. It rippled out and laid the foundation for civilization itself. It really all starts here, with something simple and physical. We could now make better, sharper, and much more reliable tools with way less effort. Right, so you have better tools. That means you're better at hunting, better at gathering food. And with that kind of food security, groups didn't have to be so nomadic. They could start to form more permanent settlements. And for the first time, people could specialize in things other than just finding food. And once you have stable communities with people who can specialize, you've got your tool maker, your hunter, your builder, well, that's when you get the fundamental building blocks for complex societies and eventually civilization. And you can see this direct, unbroken line running all the way through history. The knowledge of temperature control that we learned from heat-treating flint is the direct ancestor of smelting ore for the Bronze and Iron Ages. That, in turn, leads right to the steam engine, which is all about using fire to boil water for power, an idea that probably got its start with stone boiling tens of thousands of years earlier. So, the big takeaway here is this. Fire wasn't just for keeping warm. It was the catalyst. It was the force that allowed us to manipulate the physical world on a fundamental level. It taught us cause and effect. It taught us process. It showed us we could literally re-engineer the world around us. Which, kind of leaves us with one last big question. If fire was that first general-purpose technology that transformed absolutely everything, what's the fire of our time? What discovery happening right now is acting as that same kind of catalyst, unlocking possibilities we can't even begin to imagine yet?